started now. Let's start the recording. Good afternoon, everyone, and welcome to today's webinar, Orchestrating DevOps from Customer to Code, Integrating Development Management. Today's webinar is being recorded, and you'll receive an email with the link when it's available. Today's Q&A session will be handled electronically. You'll see a Q&A panel on your Zoom interface. Please enter your questions there, and our presenter will address them during the Q&A portion of today's webinar. Our presenter today is Joe Schultz, AVP of Emerging Technology with Orchestrating. I'll now turn it over to Joe.
All right. Well, thanks, Chris, and welcome, everyone. This is webinar 2 in a 4-part series. We started last month with introducing the idea of orchestrating DevOps from customer to code, or what we call continuous flow integration. And last month, we talked about integrating customer request management, so all about the front end of the cycle. And in this month's webinar, we're going to talk about integrating development, so getting the developers and development planners involved in the process as well. As you can see, we have 2 more webinars coming up in March and April as well to extend the process, to talk then about quality assurance and test management, as well as metrics analysis. So stay tuned for those in the future. As Chris said, my name is Joe Schultz. I'm AVP Emerging Technology at Orchestrating. So what I do is look at tools and help customers deploy new technologies in their organization. I've done a lot of work with lots of different development tools, and of course, everything promises the ultimate in productivity and efficiency. But what I've found over the years is that integration is often the backbone of any good process, particularly with respect, of course, to automation. Reducing those cycles and reducing the time to market is all about how quickly you can integrate one process or one stack to another. And so that's what we're going to talk about today. That's what the focus of this webinar is reducing those cycles, reducing cost, reducing inefficiencies, and removing bottlenecks in moving to production. So specifically, we're going to talk about continuous DevOps flow integration, kind of a mouthful, but that's what the focus of this webinar has been all about. And then we're going to dive particularly into the development process today. And I'll even show you the tool that I'll be describing, which is a product named ConnectOn. So this is all about flow integration. Now, you've heard these terms before, I'm sure. You've heard people talk about continuous everything, right? Continuous integration, continuous testing, continuous delivery, continuous verification. Flow integration, or flow, is a new term in the industry more recently. And it's all about measuring and shortening the cycle between the various steps in the process. So Orchestrating has done a lot of work around this idea, and we call this kind of consolidated process continuous flow integration. And continuous flow integration to us is all about automating transformation across all the stages of your life cycle. You know, it's all about, as I've discussed before, bidirectional feedback and real-time notification, you know, keeping track of what's happening and making sure everyone in the process understands what is supposed to happen and what has just happened both. And it's all about really about removing manual process. You want to increase automation as much as possible so that you don't have people or wait time being the bottleneck to moving to deployment. Now, I went over this picture yesterday and last week in a lot of detail. So I talked a lot about the overall process. It all, you know, basically boils down to requests coming in from the customer that flow through development into QA to make sure that we satisfy the original problem or request, and then ideally capturing metrics along the way. So this large process is what we call continuous flow integration. And in the last webinar, I focused particularly on customer request management. So I talked about using customer request tracking tools to get customer feedback around defects, potential bugs in the software, as well as enhancement ideas, you know, letting the customer request new features, and how those integrate then with your DevOps planner, who decides what's going to go into what release. You know, an architect of some sort, who manages that backlog of customer requests and decides how best to package those requests into the deliverables that we can then produce. Today, then, what we're going to do is extend that conversation to talk about how development gets involved, how we move from that customer request through that DevOps planning stage and then into the actual development planning, which is, often sprints and releases and iterations and, whatever you want to call them. There's lots of words that lots of tools use. But the point is we're packaging those strategies that the DevOps managers put together into some deliverable piece of functionality. The most common object types that people use are things like epics and stories, for example. So a DevOps planner might create the epic, which identifies a general aim, and then a development planner will break that down into individual sprints and releases and cycles in order to identify the minimum viable product that we can create in each stage, to break it up into small little pieces that can be developed in either in sequence or in parallel in order to create a piece of functionality that produces some business result against that epic. So it's that drive from the original customer request, which might just be, hey, I need something to do this, to be able to track my order in real time, through the individual pieces of functionality, things like, a module to write an email injection, or a module to track movement from node to node or station to station or delivery process, things like that. So each of those would be individual functions, minimum viable products, that would deliver a piece of that overall epic that the customer really wanted. So that's the idea. That's what we call integrating development management. The idea is to get the developers, all the way down to the individual line of code or contributors, into the same process and have them talking back through what I showed you last month, all the way to the customer-facing organizations. Now, when we talk about development management, though, more specifically, we're thinking about things like, as I mentioned, the sprint planning and prioritization, but we're specifically targeting things like stories and bugs. We're looking at the features against which a developer will develop code, some sort of module, whatever that is. And when I say code, that's a very generic term, of course. Code may be actual, written code like we're used to seeing, thinking of code. But code could also be new templates or style sheets. It could be changes to design artifacts. It could even be as simple as changing icons on a screen to make them more readable. So, when I say code, it means a change to the delivered system in any fashion that accomplishes some business goal. And the whole point of integrating development into this process, of course, as I mentioned, is to avoid wasting time. We want the developers to be able to work on things immediately, to know what the priorities are. The whole idea of Agile came around years ago, and we introduced this concept of sprint meetings or stand-up meetings. And these are more focused kinds of sessions than traditional status meetings where, we sit in a room for hours with a boss. Usually they're more focused than that, they're more efficient, but nevertheless, they still require human intervention. They require me as a developer to stop what I'm doing, put down my cup of coffee, and walk into the boss's office. And so for the duration of that stand-up meeting or that status report, there is no productivity coming out of me. As a developer, I'm not contributing. So we want to automate that process as much as possible. We want the developer to stay at their station and see the changing artifacts in real time. So the only lost time that I have as a developer is actually looking at the screen to see what's changed. I don't have to sit and listen to someone else talk about their artifact that I may or may not even be interested in. If I need to be interested in it, I'll electronically notify the system that I need to know, and I'll find that out electronically. And we can do that with the tools that we have in place today. That's what tools like Jira, for example, which we've talked about before, are great at. They're great at notifying people who have an interest in a particular object or idea, or in our case, stories and bugs. And so if I care about that particular feature, I get notified, and if I don't care, I don't. So it's selective notification and it's real time, which avoids a lot of extra work on my part. I don't have to monitor these ever increasing inboxes of emails with spurious notifications that I could care less about. And then we also want my input to flow back to the customer-facing organizations. I want the help desk guy who talked to my actual customer to be able to tell them exactly where I am in the process. You know, have I started that delivery yet? Am I in the middle of it? Is it completed but waiting for verification? Has it been deployed to production? Rather than me having to tell the help desk people and send email or have a status meeting again, that information should flow back to the customer-facing organizations electronically so that we can notify our customers immediately. Ideally, it could even flow directly to the customer if we wanted to allow that. So it's extending that same process I talked about last time down to the development organization so that everyone from customer to code is involved in this integrated process. There are a million examples, right, that I could talk about. I always try and pick one example for each webinar just to show you something in real life. We all know lots of examples of software projects that have failed because of missed deadlines and because of gold plating where the developers have done things that weren't supposed to do or whatever. One of the things that is often used as an example is this F35 Joint Force Striker project. I'm sure many of you have heard this. I like this example because it's very well known and people understand the concept. You know, in short, this is a $1 trillion project to develop the next generation fighter jet. And as of the beginning of 2019, there were over 100 Category 1, that's critical showstopper kinds of issues that were related to software problems. And the vast majority of these are related to the exact problem that I just talked about. It's that developers either don't know of what's going on, or they spend so much time in status meetings and projections that you know, they're not getting their work done on time. So there's a lot of cost overruns, a lot of delays in this project, you know, in general. One specific defect, for example, that I like to highlight is this target identification software. So the problem we had here is that the software was designed to identify incoming threats. So, you know, jet fighters flying around, the software is monitoring the radar automatically to try and notify him of incoming threats. And when it detects a threat, it highlights it and actually enables the system to respond so that it makes it, shortens the response time of the fighter pilot so that they could respond to a threat by firing a missile or taking evasive action or whatever it might be, changing altitude. The problem that they had, though, was because these developers were working in silos, different parts of the application construct, there was a feature that you know, didn't work the way it was supposed to. And in this particular case, the result was that it would identify different planes flying in formation, would identify the same one target as multiple targets. So suddenly on my radar, I would see 12 or 15 incoming threats at various positions because they were based on the positions of the other fighter planes in my formation. And it was all because software developers were writing these pieces independently of each other and didn't have access to each other's components until it was too late, until this software went all the way into trial, and that's when they noticed this problem. So this is just a simple example of communication across the development space from planning to development space, causing, in this case, hundreds of thousands, probably millions of dollars in delays against this $1 trillion project. And that's just one of, as I said, you know, 100 examples in this particular project alone. So, you know, as we all know, software is ubiquitous, software is in everything, and these kind of problems then are rampant in our world. Now, the example that we showed last webinar was customer requests. So we took, for example, a ServiceNow request and talked about how it would move through an integration product named ConnectAll and show up in Jira. So the idea is a customer puts in a defect or an enhancement request, either one, into their front-end system, and that traverses through the integration, the automated integration that is ConnectAll, and shows up in Jira automatically. The Jira planner then can take that item from the backlog and put it in the appropriate place. They can prioritize it into epics and sprints and releases as necessary. And the help desk then that originally came from is kept in sync as well. So when those changes are made downstream, the customers get notified either through the help desk or potentially even electronically through the help desk software itself. And this is all enabled through an automation interface so that no human has to be between those two steps. The customer enters their request. The next thing that happens is the Jira person sees it on their backlog. They assign it to a sprint or whatever, and those changes along with the anticipated release dates and whatever else is important for the customer to know flows back into, in our example, ServiceNow. And so this week what we're going to do then is take that same concept and move that forward into the development world. So that same request that we talked about before would then become an actual deliverable within the development world. Now this could be one object. Maybe it's a bug report that someone put into ServiceNow. It flowed into Jira, got added to the backlog for a sprint, and that shows up as a task directly for the developer to work against. So there's a lot of ways this could happen. It could also be coordinated as part of a larger transaction or as part of a smaller set as well. It could even be transformed along the way. So for example, that one bug report may end up exposing a deficiency in the product that needs to be re-architected. And so that one bug report could then become a bunch of tasks, for example, that have to be done across multiple components of the product. So it's not necessarily always a one-for-one. That the way that flows through the system will depend upon the nature of the defect. It will also depend upon the nature of the process that you want to employ. Some people, for example, have user stories flow directly from Jira into Azure DevOps as stories, and the developers will work on story objects. Other people prefer to take that story, which is related to the customer request, and then break it down into tasks, for example, which might flow then into Azure DevOps as the tasks for developers to work on. And of course, you can mix and match those things. I mean, it's completely up to you at how you implement the process. The point is, in ConnectAll, you identify then the integration points and the way that data is supposed to flow from beginning to end. So you tell ConnectAll, for example, which information is supposed to transform, how it's supposed to transform, and where it'll end up. And so in our example here, I've got essentially an open communication line from the customer through the planner into the actual coder development manager as well, through 3 different tool sets, all coming from the one integration spot and kept in sync. So that's the idea. That's how it works. So now, I'm sure what you want to know is how it works and how it actually looks. So let's get out of PowerPoint here for a second and pop over into ConnectAll itself. Let me bring that tool up. And if you were on our last webinar, you've seen this before. This is the main ConnectAll interface. It's essentially where you define your integration points. We call those integration points application links. So over on the right-hand side of the screen, you can see I have a whole set of application links for different purposes. The one that I have enabled for this demo is something called a Jira Story to Azure Story. That's just a name that I gave it. What that will do is monitor the 2 endpoints and look for changes, in this case, to stories. So when the DevOps planner, for example, or development manager creates a story object that we want to assign to a developer, that assignment probably will cause it to flow then into Azure DevOps as a user story that a developer will work against. And it'll get decomposed into tasks either in Jira or in Azure, or maybe neither if you don't use task allocation. So you can control how that data moves back and forth. To create one of these new links, it's literally a matter of point and click. So I can just drop down from the drop-down menus, the endpoints that I want to work with. So in this case, Jira and Azure DevOps. I give it some kind of name, and I create a new link with this Map Apps button. That will create then one of these new links. To define that, it's simply a matter of walking through a three-step process here. The first step is to identify the servers that you're going to connect to. So you can see I've got Jira on the left-hand side, and I have VSTS or Azure DevOps on the right-hand side. Now, the right and left makes no difference in terms of connect all because all links are inherently bidirectional. You can control that, of course, but I do this just because to me, it's moving left to right. That's the way I think about it. But realistically, in the tool, it makes no difference. The second step of the wizard then is to identify the objects that you care about. And so, for example, I can pick literally any object that's supported by the Jira server. You can see I've got a half a dozen in this particular Jira project. But if you created custom objects, they would show up as well. Or if you have other Jira plugins, you would see other object types in the list. In this case, I want a Jira story to flow down into Azure DevOps as a user story. Again, you'll see it supports essentially all the object types within the relevant server. I can also do things like specify additional poll queries. This poll query is a filter. So I said for a minute ago that we may only want to do this if the user story is assigned. So once the user story gets assigned, I want it to flow in Azure DevOps. So I could literally put in a JQL Jira query here. So I could say, for example, is not empty. And so now that query will become a filter on the Jira side, and only those objects which are assigned will flow into Azure DevOps. Once they flow down, then of course, updates will flow bidirectionally as well. Yeah, I mentioned you could also control the directionality of those links. So this sync operations option control that. By default, connect all is inherently bidirectional. But I can, for example, say, well, I don't want new stories that are created inside of TFS, VSTS, to flow back to Jira. Maybe we're going to decompose that user story into smaller pieces in the development tool, and we don't need that to flow back to the planning tool. So I could turn off create, for example, but still get bidirectional updates. So you can simply, by clicking a few checkboxes, control how this information flows back and forth. So that's the second step. There's a couple of clicks to identify the scope of the integration link. And then finally, the last step is just to identify the fields. And this is just like the two steps before, a matter of pointing and clicking. I get a list of all the fields from both sides. Connect All goes out and inspects the servers and creates this list of all the fields that are relevant to the scope and that you specified on the previous page. And then you just create a list of fields that Connect All is going to monitor. So for example, you can see in this example, I've got half a dozen fields that are being bidirectionally synced, things like title, description, priority status, even attachments and comments flow as well. And then I've also got some control information like identifiers that are only flowing in one direction or another. So for example, the identifier from VSTS will flow back into a custom field called Azure DevOps ID in Jira, and vice versa. The Jira key will flow down into a custom field in Azure DevOps called Jira ID, so that I can see the control information on each side. So you can control all of this, which fields are monitored and how they flow simply by pointing and clicking and dropping arrows down. In some cases, you'll see that fields also have value mapping assigned. So if I'm just flowing a description back and forth, that can happen automatically. But if I want, for example, to be able to transform the data in flight, I can do some value mapping where I identify, for example, like in this case, that the value new will become to do or vice versa. So that's a bidirectional flow. And you can see that I can build complex flows in here. You can ideally create any kind of transformation logic that you need here. Most things can be done with the mouse. I can literally just click on this little pencil icon, and I can fill in a window with the characteristics that I need to map just by clicking from the lists. these are all inspected from the servers in runtime. So, this is the definition of this object coming from the server, the relevant server. In this case, Jira is on the left, and Azure DevOps is on the right. I can also drop into code if I need to. So most things can be done with point and click, but if I need to, I can also drop into code, and we support a half a dozen different coding languages, and you can write little snippets to do transformation. So I could write a snippet, for example, to do a conditional transformation that may not be possible with the drop-down option. We find often that that's clearly a minority of the time, and it's a 5% of the time that you'd have to drop into code. But it is there if you need that capability to get into programmatic type transformations. And that's all there is to it. It's a matter of, as I said, identifying the server, identifying the object scope, and then identifying the field mapping. That three-step process then creates for us the application link, which then monitors the environment. If I need to monitor the actual work that's going on, ConnectAll has a dashboard which will show you the activity that has occurred. You can look at either a historical activity. So, for example, I might want to look at all of the successful syncs that have taken place, and I can see the actual timestamp and object IDs for everything that occurs. Or I can also turn on a real-time monitor here as well. I can literally watch messages flowing back and forth to see as objects are created and updated on either side. Now, in reality, nobody's going to sit here and watch this monitor. I would normally only do that during debug kinds of mode. Generally speaking, what's going to happen is I'm going to be monitoring occasionally this success list, or more importantly, I'm going to be getting notified when there is a failure. So whenever a failure does occur for whatever reason, maybe a conflict in updates across the two servers or a rule that's been violated, then I'll be notified however I choose to be notified, through email, for example. And then I would come in here and I would inspect it. And I might, for example, then inspect what happened in this error. And so in this particular case, if I scroll over, I can see that in this example, we had a duplicate name. So one tool allowed duplicate names, the other did not. And because of that, I got an error when we tried to sync it. In this case, it was a Jira object syncing to a testing tool. And so, I had a problem with a name collision. I would fix that error. I would, inform the developers or planners that that's the problem. And then I can even retry that right here within the dashboard as well. So a wealth of tools for the manager of ConnectAll to analyze what has happened, what is happening, and then correct any errors that might need to be corrected. And so that's all there is to ConnectAll. It's very easy to set these links up, as you just saw. We can set them up in minutes, and we can monitor any of the endpoints we want. This is just one example where I was talking about Jira stories to Azure Stories, but at a larger scope, it's like we discussed before. I just showed you the product. ConnectAll can monitor any endpoint. So we were talking about ServiceNow linking to Jira, linking to Azure DevOps. ConnectAll supports over 40 tools, 40 endpoints, and has the capability to support custom endpoints as well. And so you can literally build any kind of integration platform across any number of tools with this technology. The actual list is largely DevOps types of tools, and that's, of course, the focus of this webinar is continuous DevOps flow integration. But we do reach into things like project management tools or proprietary databases. We can talk to a whole variety of operations tools as well. And so there are lots of other uses beyond the ones that I'm talking about in this webinar. We do, as I mentioned, also have a custom adapter for both APIs and for databases. And so we can literally talk to anything that you have an electronic access to, whether it's a proprietary system that you've built that uses its own database, or whether it's some application package that has an API. As long as we have some layer that we can talk to the data at rest or the data in flight, then we can integrate that with the other products in the environment. And so with that, I'm going to turn it over to questions, and we'll see if we have any interest in other aspects that I haven't maybe covered. There is a chat window, as Chris mentioned, so feel free to enter your question in the chat window. I'm going to pop that open real quickly right now and take a look at it, see if we have any questions that have come up so far. Okay, so here's one. It says, does Connect All require plugins in the IDE? I assume by that you mean the development environment, in order to work with custom object types? And so the answer to that question is no. Connect All does not require plugins in any of the environments, in fact. The example that I just showed you was Jira and Azure DevOps. Like almost all of the integrations we have, those talk directly to the published API from the vendor, and so they don't require any plugins in the vendor's environment. So there's no plugins in Jira, no plugins in Azure DevOps. Instead, what we do is we interrogate the servers on a scheduled basis, and you can control that schedule. Usually it's 1-minute cycles so that it's very small, efficient packages. And then what we do is we get the results back from the API and process from there. And so everything's done through the published APIs through the vendors. That makes Connect All very version resilient. It also makes it very stable as well. So we're not generally worried about changing releases of products as well, because the APIs are generally very stable from all of the vendors. There's another question. It says, do all customer requests have to end up in a development project? When I read that, I see customer requests. I assume that means customer requests I talked about coming from something like ServiceNow. So I'm assuming the question is asking about, does everything in ServiceNow have to end up in Azure DevOps? And the answer, of course, is no. You can control those criteria, as I discussed, with a variety of mechanisms. But the point is that one request might come into Jira as a backlog item, and that backlog item may or may not flow down to Azure DevOps. That backlog item could also become multiple requests, as I mentioned, inside of Jira. And so it's not a one-to-one correspondence necessarily. You would build the rules that suit your particular work model in order to make that happen. And then finally, I'll take one more here. We're just about out of time, but I did have one more question, which was, can Connect All work with existing projects, or do you have to start new projects each time? And so the answer to that is that it can actually do either. The default model that I've been talking about is some new project where a new request in ServiceNow becomes a new story in Jira, which then becomes a new task, let's say, in Azure DevOps. But we can also work with existing projects as well. So you might have maintenance projects, for example, that are not handled in a quite the same agile method as your new development projects. And so you have existing components that you want to be able to link, and Connect All can do that too. We have a variety of ways to link across projects. The most common technique for something that's existing already is something we call dynamic linking, for example, where you can tell Connect All how you want to link those across. And so that works well when you have existing projects that already have some of the artifacts, and you just need to tell us essentially which ones go together. Objects then that you don't designate, you could have flow across as new objects. So Connect All can do the replication for you across products, or you can have it just synchronize updates on existing objects that you identify. So that's something that you could set up at the beginning of your project, and you could mix and match that as well. Okay, that's about all we have time for today. So I thank you for your attendance. Do keep in mind we have a free consultation offer. We mentioned this on the first webinar as well, that we will provide a free 1-hour session to all live attendees of these webinars. So if you'd like to take advantage of that offer and and set up a consultation session with us at no charge to you, feel free to contact me at my email address there. It's joe.schultz@oracy.com. That's S-C-H-U-L-Z with no T. I also wanted to mention that our next webinar is March 17th. So this is the third in the 4-part series. And in the next webinar, we'll be talking about how to add test management into the same integration pattern that we've been discussing. So, by now I'm sure you're starting to see the thread here, right? We started with the left-hand part of the cycle with the customers, and we're working our way all the way through to deployment, essentially. And the last piece of the big trinity in the development space is the quality assurance or test management kinds of tools. So that's what we're going to talk about in the next webinar. And that's on March 17th at the same time. You can contact Oracy Sales, or you can use our website as well to sign up for this webinar. And with that, Chris, I'll turn things back over to you.
Thank you, Joe, and thank you everyone for joining today's webinar. Again, it was recorded and you'll receive an email with the link once it's available. If there were any questions that popped up at the last minute that we weren't able to address live, we do have a record of them and we'll address them offline. This concludes today's webinar. Thank you and have a great day.